We're looking at the first year core textbook and we're on mixed exercise 5, which is on straight line graphs, and we're looking at question 2. Okay, so 2A, so it's an exam question, which is really handy because I can see how many marks each bit's worth. So if I'm answering part A and I've been working for a page, then I've probably gone a bit too far. We missed something. So 2 marks shouldn't be too bad. And it's to show that question, so I must be sure. I shouldn't use k as 2. I just know that that's what I should end up as my answer for k. Okay, so they give me the gradient. So I am going to use that the gradient is change in y over change in x. So I know that the gradient is a third. They tell me that there. Doesn't really matter which way round I subtract. So I think I'll do this coordinate, subtract that coordinate. So change in y is going to be 2k minus 1, and then minus 1. And then I just must be consistent. So when I do my change in x, I must also do this one, subtract this one. So that's going to be 8 minus k. That doesn't really look like a k there, does it? Make that look a little bit better. Okay, and then so that's only one unknown. K is my only unknown, so it's just a case of tidying that up. So I'll do it in a few stages just so I don't get lost anywhere. So I'll just tidy up that numerator. Then I'm going to multiply up by the 8 minus k and up by the 3. I'm just going to cross multiply. Okay, so this is probably a bit more work than it should be for 2 marks, but with a show that question, I always want to be on the safe side. Make sure I have definitely clearly shown where everything comes from. So if I add the 6 over and add the k over, I get divide through by 7. I get k is 2, and it was a proof or a show that question. So I'm just going to finish it off and say as required. Okay, and then B, find an equation for the line through A and B. Okay, so we could have answered this without getting k as 2. So if for any reason you'd had an issue with the first bit, you can, and obviously this bit's worth more marks as well, because they obviously told me k is 2. So I've got, so if I substitute that in, so coordinate A, therefore I know is 2, 1. Coordinate B, I know is 8. And then if k is 2, that's going to be 3. And I know, to be honest, I don't even need the gradient, but I do also know the gradient is a third. So I think the quickest way to get it from that information is to use, I'm going to say, sorry, get all that right. Okay, so the quickest way is y minus y1 is m times x minus x1. So I'm going to use the gradient in just one of the coordinates. Really doesn't matter which one. So there's my m. Let's use a, but really doesn't matter. So y minus my y coordinate is my gradient times x minus my x coordinate. It doesn't say how to give it, like what form to give my answer in, but I can't leave it like that because I've got to collect my like terms together, and I'm going to have a constant on this side and a constant on this side. So I'm going to multiply through by 3. So that will cancel the third, and then those brackets are just being multiplied by 1. And then I'm going to bring everything over to the left-hand side, but you don't have to ignore that. Pretend that didn't happen, right? You don't have to give it in that particular form, but what you must do is collect those 2 constants together. So it would be absolutely fine to give it in the form y equals mx plus c, in which case you should have ended up with a third x plus a third. Okay, but any correct, as long as it's fully simplified, any correct equivalent is fine. Yeah, that's what we got. Cool.